the proportionality constant in K, and the second equation that after experiments, when experiments and electrostatic of the charges, when they need a lot of studies and a lot of experiments, they come up with this equation. So we say that, okay, there's a relationship between this equation. So K, we can substitute K, that's what we say, that's substituting question 2 into question 1. So the positions of K, we introduce the 4 pi of the free space. And this is what, again, with questions, but this for the free space of the medium, we were indicating that this is the proportionality or the electronegativity is the proportionality constant. Right? So proportionality constant that's showing electric field properties, talking about electric field charge. Then we said that any electric charge, the electric permittivity is related as this simple, right? It's absolute. So listen, the first general formula of either positive or negative is given as the second product of lecture. So we say that the force is equal to products of the lecture charge, 1 each 2, F over 4 pi permittivity of the medium. The same property of the distance. So this is the permittivity of the medium. Electric charge don't confuse this permittivity of the medium, permittivity of the free space. This is a positive or negative medium, which is free space. This is where n is integer, right? So now I want to take you out of fantastic last term of this lecture is called relative permittivity, right? Or the electrical charge. However, the students here. Building the foundations of electrostatic. We are still in introduction. Okay, so relative permittivity or the electric constant. This is okay. Fundamental question, you know, always whenever I can tell you know what is next thing, right? And then to learn another property that's really I can tell you that what I've been told for teaching electric charge is what I've been told between themselves, which is inversely proportional to the square of the distance apart. That is, I'm going to teach you. These are the techniques that when I write a property, regardless of the electric charge does not or electric charge is a scalar quantity. Electric charge is 6 magnitude of the charge. So then we say that on this video, now this is question 3. Okay. So we say that this we have the signs. So we say that the first stage is all about you. We say that in place the first law we say proportionality sign, right? Proportionality sign, right? Fundamental laws. Proportionality sign with there are 2 laws. Equal with equal sign and the constancy K. What does it mean? That means that now study place this position of proportionality sign with equal sign at rest and the constant and what proportionality. So this is equal now to the proportionality constant K times the product times due over square of the distance between the 2 charges. This is literal. It means that literally, in general, many teachers they used to teach in this place. But I would like to say that it's the quality of the low level studies. So long mathematical, it's not difficult. Long mathematical questions. Okay. Say that mathematical question. First law state that mathematical question according to the physics fundamental is this, right? Is this. So what is it? Law is force, scalar quantity, or vector quantity, or vector quantity. Is Q quantity is charge, scalar quantity, or vector quantity? Take the property say it is scalar quantity. So if force is a vector quantity, you have to show its property of vector. Like electric vector. So vector quantity is a quantity which are both magnitude and what direction. So this is the directions of the force. These are right. So then we say that this is equal to what? The proportionality constant, which we'll discuss this too soon. Okay, so this is Q1 times Q2, and then divided by the square of the distance between the two charges. But also we say that on this right hand side, I have a vector, we call it directional vector, light charge. So we call directional, that's iron, it's a good conductor. Okay, so we have iron. Even a human being also is a good conductor of electricity. So you can mention more conductors, and also we told you about insulators. Then we left here homework for you that you have to mention properties of electrons. But we touched a little bit about the quantity of charge. We say that this is equal to current electricity times time. So we left your homework, which is all about properties of electrons. So before we start this session, always you have to make sure that you are surrounded, right? So you are surrounded like this. Okay, so today I want to demonstrate to you in a different way. You are surrounded. You are surrounded with this stuff when we'll be taking this lecture. So you are surrounded that here. This is a syllabus, physics, advanced physics syllabus, right? You are surrounded with it. And then so on this side, I have a fantastic textbook which is called Principles of Physics. And then on this side, I have a question and answers which is called the Physics 2 Review for Electrostatic. Physics 2 Review for Electrostatic. So you'll find many examples or many questions of electrostatic in this book. So when you'll be taking, think like that once. Because myself, when I was preparing this lecture, I've been surrounded with this book. And even if that when I'll be teaching you, my mind is surrounded and overwhelmed with these books, right? So let us go to the business. Today, I want to take you to somewhere, okay? So, when we say about laws of electrostatics, basically, I'm going to teach you two laws. The one is the oldest, because you know it. We'd like to start in this case. So, did you find, okay, properties of electric charges. Did you do that homework? Let me ask about my physical students. Did you do it? Can you come and present, or can you come? So the first property of electric charge. Speak loudly.
Negative charge.
Pardon?
Negative charge.
No, that's not a property of electric charge.
They travel in a straight line.
They travel in a straight line. Okay?
They may be deflected.
How many did they ask you to mention? Did they put a limit?
No.
Anyway, so this is a correction for all because my spending much time, maybe you are not well prepared. The first property of electric charge, I won't read. I won't write. I'm reading. The first property of electric charge, they are either positive or negative in nature. I ask you properties of electric charge, not electron, right? Possibly, if I have made a mistake, you can make that correction. I asked the questions was, mention what? Can you read the question?
You say the properties of electrons.
Okay, thank you. Sorry, Johnson, you are right. Correction of 40. Homework 01. Right? Questions? Ask you. Mention. Read the question.
Briefly explain the properties.
Okay, briefly explain the properties of what? Properties of electron. Okay, so this is how I wrote. So cross this one and then properties of electric charge. Because electric charge, when you say electric charge, you mean positive and not negative charge. So listen, the first one, they are either positive or negative in nature. The second property, like charge repel and unlike charge attract each other. Okay? That's the second one. The third property, electric charge are quantized. The charge on the object is either positive or negative, Ne, where N means integer, E is sorting electric charge, which is 1.6 exponent negative 19, right? So it means that the charge of electron is negative 1.6 exponent 20 exponent negative what? So negative 19 Coulomb. And then the quantity of charge for the proton, for instance, this is positive 1.6 exponent 20 negative 19 Coulomb, right? And then another property, that will be the fourth one, if I'm not mistaken. The electric charge produces force between themselves, which is inversely proportional to the square of their distance apart. That is Coulomb's law that I'm going to teach you today. Okay, the fifth property, we say that electric charge is a scalar quantity. Electric charge is not a vector quantity, it's a scalar quantity. Then the seventh, or the sixth property is magnitude of the charge on the body is independent of the speed of the body. The magnitude of electric charge on a body is independent of the speed of the body. So for instance, if I contain charges and then I run with a speed of, let's say, 20 meters, maybe let's say 20 or 10 meter, or let's say a distance, I can run a distance of 2 meters per second, right? So it means that the magnitude of the charges within me, they don't depend on the speed of my body of running. Okay? So those are the 6. You can add up in case that you found more than that. But in case that you found that I've been speaking quickly, you can replay. It means you can watch this video several times. It means you can play back. Okay? So the first is, so we have 2 laws that we are going to learn today. So this is all about in previous session. The first law, we say that, okay? So we say that there are 2 fundamental laws. Okay, there are 2 laws that govern the study of charges, electric charges at rest. The first one is called the fundamental law of electrostatic. Fundamental law of electrostatic. Okay? That's the first law. This is the oldest thing. You know it because you covered it. You covered this law during your O-level studies. Okay? So you covered this law during your O-level studies. And this law is it's not difficult to state it. You say that the first law states that, so the fundamental law, okay, fundamental law of electrostatics state that, like electric charge, okay, repels. This repels, do you have R? Repels, yes, repels each other. Repels each other, right? While unlike charge attracting each other. So you know this one. So what does it mean? Okay? So the fundamental law of electrostatics states that like charge repels. And the second part, unlike charge attract each other. So let us start with this sentence just to explain. Like electric charge, get prepared to enjoy the beauty of physics. Like electric charges repels. So because it is more than one charge, so we omit this one because this is the verb. Repels and like charge attracting and like charges, right? Like charges attracting each other. So that's why, because you know it's plural. The noun is plural. So like electric charge repels. What does it mean? This means, for example, if this is the charge 1, which is positive charge, and here again you have another electric charge, we bring them closer, just like this one is another electric charge. This is the Q2, okay? So this is what positive charge. Suppose that Q1, this is equal to 2 Coulomb, right? However, that is not existing because we think that the SI unity of the electric charge is Coulomb, but practically it's not, does not exist, right? Why? Because the large magnitude in physics. So what do we use as alternative? Because I told you that we have Coulomb, we have another unit we call it millicoulomb, also that's the large size. It means we can find it in physical. It means that in practice. And also another unit we call it microcoulomb, right? So it means that suppose Q1 it is 2 microcoulomb, right? And also Q2, suppose also Q2, but is positive, right? Q2 it is positive 3 microcoulomb, right? So what happens? Because these are the like charge, they are going to repel each other. So this one is going to repel Q2, going to repel what? Q1, and Q1 is going to repel what? Q2. So what the meanings of repel? Push. So the kinds of the push, right? That don't come close to me. That's the meaning, right? So the kinds of the push, which is mechanical force. So now, again, that is all about that is in case of the positive charges. So this is the demonstration for the positive charges, right? And then number 2, if you have negative charges, that we say that these charges are negative electric charges, right? Charges. So here we have this charge and this charge, right? And then this one is negative Q1, and this one is negative Q2, right? So this one also it is 2 microcoulomb, but is negative, and also so negative in sign, okay? And then this one is negative 3 microcoulomb, right? But this is negative. So what's going to happen? So even this that suppose that they are coming closer. So this one and this one, they will be repelled. So listen, suppose that the force produced by Q2, it is F2. So F2, it's the one that is going to push Q1 this side, right? And then this is, suppose it's going to produce a force we call it F1. So F1 is the one that is going to push your Q2, right? Similarly, this is what? F2. And this one is what? F1. That's the meaning of 40. That's the meaning of that fundamental law, right? Okay, there's a distance here, but we don't take considerations of the distance right now. So that's the meanings of 40. Like charge repels. So if it means that if you bring 2 electrons together, regardless of the magnitude and quantity of charge, they are going to repel each other, right? And hence we go. So this is very important. Make sure that you note this point, okay? Because you used to claim the law we don't understand. Because if you don't understand this context, you will be getting troubles on solving questions of electrostatics. Because this matter, right? If you have like charge, something is going to happen. If you have unlike charge, something is going to happen. Sometimes if they attract, there's the issue of cancellation, balancing of the forces. Because when you say they attract each other, means each other is attracting, regardless of its magnitude of the charge. So it's very important, and let me put here, this is tough so that you can see, and the zoom clear. So we go for what, this is B. B, I want you to explain what the meaning of unlikely charge, say unlikely charge, unlikely charge, unlikely charges, okay, attracting, right, attracting each other. So let us demonstrate unlike charge. So this one, we have only one demonstration. So okay, so here we have Q, and here also we have Q. So this is Q1, right, unlikely charge, but this is supposed is positive. And then its magnitude is 2 microcoulomb. And then this guy, it is what is negative Q2, okay? And its charge is negative 3 microcoulomb. These are what is unlikely charge, right? So they have different, they might have even the same magnitude, 2 microcoulombs and negative 2 microcoulombs, right? So what is going to happen here? Fantastic. So suppose that this one is going to attract this charge, okay? So this is Q2. So this one is going to attract the Q2 in this side, okay? So it's going, telling Q2, come on, come on, come on. So this is F1. Come on, come on, come on, Q2, right? And then this one is going to attract what? Q1. So the direction of the force is this one. So this is what you call F2, right? So that's what, so it means that now in physics that we say we have Q1 and Q2. This is Q1, which is positive, and this is Q2, which is what? Negative, right? This is negative. So what is going to happen? So we have a line. So this line, we say that we used to show that these directions. What does it mean? Mean that Q1 attracting Q2 and Q2 attracting Q1. Fantastic. All right. Remember the fundamental laws of electrostatic. It's a fundamental of the next law, which is called Coulomb's law. If you understand what's going on here and you combine with Coulomb's law, I'm telling you that you'll be dangerous in physics. Right? That's the promise that I want to give you. Okay, if you have any question, ask in the comment section. Remember to subscribe. We are going to upload more than 500 videos in this YouTube channel of Tanzania Online A-Level Safety School. Okay, so make sure to subscribe. Okay, so I think that it's enough. If I want, this doesn't mean that what I know, but it's enough for you, right? Because I can take you further and then we can turn the fundamental law of electrostatic to become just like a subject. Another thing, before I end, we say that if that the case, the quantity of charge, we introduced this one in session 1, is equal to electric current times time. Because yesterday also in session 2 we defined what the meanings of Coulomb, right? Then say Coulomb's, what the Coulomb? Coulomb, you remember it? We say that it's what? Is a quantity of charge flowing through a section of the conductor producing a current of 1 ampere in 1 second. So 1 ampere means electric current. Second means time. And also we say that this is equal, so this is, for instance, is equation 1. And as you have quantity of charge, with this we learned in chemistry, if I'm not mistaken, right? Number of electrons times what? Electronic charge, right? Or in some of the books, they use this symbol, Ne. So number of electrons times what? Electronic charge. And it is useful to find the number of electrons, right? Because this is the electronic charge for 1 electron, right? So how many electrons in the atom? Let's say 20. So it means to know 20, you know the quantity of charge there, and we divide with this one. So it means to find number of electrons, for instance, by using equation 2, we say that N is equal to Q of what? E. So you know the number of electrons may be found in an atom, right? That's the meaning. But simply say that because both of the equations give us the quantity of the charge, in physics you say that the current and time, this is equal to number of electrons times electronic charge. So what we say, so we can divide by time. We divide by 10 to both sides, right? And then save current of what? Over time. This is equal to number of electrons times what? Number of electrons times electronic charge. Okay, yeah, so this time, okay, so you understand. Okay, so time over time, so time and time cancel. So we find that current is equal to what? Number of electrons times electronic charge over time, right? So it means that if we take current, is equal to it, number of electrons over time. So divide by electronic charge. So if you divide this and this will cancel. So you find you have a ratio of what? Electric currents of electronic charge is equal to number of electrons over time. So this is a little bit important expression. That's all about fundamental law of electrostatic. Have any question about fundamental law of electrostatic? Ask me in the comment section. Now let us go to the fantastic, useful, and historical laws that called Coulomb's law of electrostatic or electrical force. Coulomb law. So now we are going to the next subtopic. Please, can you go back to your exercise book? We wrote that the subtopics or contents of the general introductions of electrostatic. Okay, so the second one, what does it say?
Describe the Coulomb.
Pardon?
Describe the Coulomb's law.
Coulomb's law. Not a specific objective. Can I have the exercise book? Oh, yeah. Okay, now have a look. Okay, take it. Thank you. Okay, we say the first contents of the electrostatic of introductions of electrostatic is general introduction of electrostatic that we've been doing, and the second one is the fundamental law of electrostatic, and the third one, so today we are teaching both fundamental law of electrostatic and Coulomb's law of electrostatic. So here we can edit a little bit our subtitle, right? Okay, we can edit a little bit because you've covered the fundamental law of electrostatic. But that's not the subject. Okay? So it is fundamental. So you can change this subtitle or title, fundamental law of and what? And Coulomb. And Coulomb's law of what? Of electrostatic. Of electrostatics. Right? So now we are going to we say that Coulomb's law of electrostatic. Coulomb's law of what? Electrostatics. Okay. The fundamental question here that we have to ask ourselves as physicists is state Coulomb. First of all, say Coulomb. State Coulomb's law. State Coulomb's law of what? Of electrostatics. State Coulomb's law of electrostatics. I have three styles of stating this Coulomb's law because it's very important law in electrostatic more than you think. So let me state it and then I'll explain mathematically. Okay? So, Coulomb's law, Coulomb is the name of the physicist. Coulomb's law state that the electrostatic force between 2 point charges, between the electrostatic force between 2 points charge, right? 2 point charge, okay? 2 point charge, 2 point charges, 2 point charges, 2 point electric charge. So a charge would represent as a point, 2 point electric charges, okay? Plural charges is directly proportional. Is directly what? Proportional to the product of the electric charges, the products of electric charges, right? You don't need to underline. I'm just trying to underline few, but I think that's better if, because you know that many students have different way of understanding what is being presented. And the inversely proportional, so even this one, let me rub it, okay? Because when you be asked in the exam, then you underline. Your teacher will ask you, what are you doing? And then you say that I've been taught by Olenjolai to do this. Inversely proportional, okay? Inversely proportional to the square of the distance, between them. So this is the end of quoting this law. Fantastic law. Let me write, so we are going to write the same law by using different arrangement of a sentence, different words, but the key words will be the same. So let me write all the three, and then I will explain to you. Are you ready for that? Do you love physics? Tell me in the comment section. You should love or you dislike. You tell me why you love it. So you say or, we can state the Coulomb's law, or say that Coulomb's law state that the force is the quotation. The force between two pointy charge, the force between two electrically pointing charges is directly proportional to the product of the charges. Is directly proportional to the product of the charges. When you say charges, it means that quantity of charge, right? Charges, and the inversely proportional to the square of the distance at the end of the quote. Or, okay, I want you to understand okay, and let me give. Are you ready for that? Can I share with you the third way of stating the Coulomb's law? Or should I leave it for you? I think because I want you to be competent in physics. Let me give you the third way of stating the Coulomb law. Coulomb's law states that Coulomb's law, okay? Coulomb's law states that, okay? I don't know if you call your firstborn Coulomb. He might introduce another law of electrostatic, right? Because of the name. Okay, so Coulomb's law states that the magnitude of attraction or the repulsion force between two electrically pointy charge, okay, pointy charge, right? Pointy charges is directly proportional to the product of electric charges, and inversely proportional to the square of the distance between them. That's how we can state the Coulomb's law of electrostatics. And explain now. The first way of stating Coulomb's law of electrostatics state that the electrostatic force. So allow me to underline to show you the keywords, because no need for you to claim this law. You have to understand it. The electrostatic force, so it has been called the electrostatic. So when you mention the electrostatic force, we the physicists, we understand. The electrostatic force, there are only two types of electrostatic force. The first type is attraction force, and the second one is repulsion force. So the word electrostatic force, it means that this is the combination of the two words, right? Either repulsion or what? Or attraction. Because like charge, we say that repel. So produce what? Repulsion force. Okay? And like charge, we say that what? Attracting. So produce what? Attraction force. So between the two, so this is electrostatic force between what? The two pointy charge. Not 3, not 4, 2 pointy charge. Okay? Electric charges, right? and then is directly proportional, not inversely, not maybe square of the distance or whatever square of the area, then proportional to the product of the area. So this is the area, the electric charges, okay? And also it is inversely proportional to the square of the distance between the two point charges, right? So let me explain this one, because something is, tell your neighbor that some physics is coming. Tell your neighbor that I understand it. I understand Coulomb's law. I understand Coulomb's law. So Coulomb's law states that in other words, the force between two electric point charges is directly proportional to the product of the area charges and inversely proportional to the square of the area distance. Some of the books, they state this law in this style. The force between two electric point charges is then proportional to the product of the area charges and inversely proportional, or not in, or they say that, and it divided it to the square of the area distance, right? Or the square of the area distance, means that of the distance between them. But this one is the one that I recommend and I like it to state in this way. The magnitude, so it means that the Coulomb's law of electrostatics gives us magnitude. The magnitude of attraction or repulsion. The magnitude, very important word. The magnitude of attraction or repulsion force between two point charges is directly proportional to what? To the product, to the product of the area, to the area product of electric charge, fine, to the products of the electrical charges, and inversely proportional to the square of the distance between them, right? You can also, whenever that, because if you like physics, you enjoy it, and you'll find it in different perspective. You can even read some other reference books that I mentioned, can find they are stating differently, but the point you have to look the keywords. So the keywords, it means that the force is then proportional to the product of electric charges, not the products of mangoes, and also the force, that force is inversely proportional to the square of the distance between those two charges. However, that when I'll be teaching you in computation, we might find that sometimes what happens if you have three charges. You have a charge here Q1, you have a charge here Q2, you have a charge here Q3. What happens there? Does Coulomb hold? Does Coulomb's law holds in that circumstance? So stay connected. I will answer you that questions later. So now, mathematically, okay, so he said that the mathematical equation of 40 of Coulomb's law. So mathematically, we just deduce from the law itself the magnitude of force of attraction or repulsion force. So the magnitude, So we have force first of all, okay? The magnitude of the force of attraction or repulsion between the two electric point charges is directly proportional. So I have 2 point charges, directly proportional to the product. You take it, quantity of the charge 1 times quantity of the charge 2. So the meanings, the product, right? Okay, the force is then proportional to the products of the quantity of the charge. Again, the second part of the sentence begin after the word end. After the word ending, this force also, is inversely proportional to the square of the distance between them. Right? So you can say that in physics, this is the first equation and this is the second equation. So now we apply mathematics in physics. So you have equation 1 and equation 2. So suppose that this is the first step of deducing this law. You should not cram this stuff. So it means that you say recall Coulomb's law. See how it means Coulomb's law. The second step is this one now. Second step, we say that, yes, so on the left hand side, because remember this is a proportionality sign. So you have left-hand side of the proportionality sign, and we have right-hand side of proportionality sign. What happens? So the physical quantity on the left side of proportionality sign is the same, right? So if the same, in physics and mathematics, you say that this one equate what? Equate equation 1 and what? And 2, right? So if we equate, we say that, okay, so the force is very proportional. Okay, we can equate with, I think that is not, okay, so he said that he combine, okay? Combine equation 1 and equation 2, right? And equation 2, so equation 1 and 2. So the force is firstly very proportional to the products of the quantity of the charge, Q1 and Q2, and then we say that it's also inversely to the distance at the square of the distance between them, right? So what happens there? Aha, so you are somewhere. What are we talking about? We are talking about a quantity, suppose that, so it means that we come to the steady state, right? Steady state, okay? On the diagram, we say that here we have, suppose that we have a certain quantity of charge, this is Q1, this is Q2, okay? So this is the quantity of charge, okay? So then we have a distance, and this actually is called mean distance, just like in gravitation. But let us take, for the purpose of learning, this is the distance between them. And then this distance between them is measured, and the result D, right? So the force between Q1 and Q2 might be attraction or repulsion. If these are like each charge, it's repulsion force. So repulsion force is directly proportional to the product of the Q1 and Q2 in terms of magnitude, right? And hence is inversely proportional to the square of the distance between the two charges, right? Okay. So if that's the case, say, well, okay. So he said that we say that the notation, so we said that not, okay, the distance, in most cases the distance between two point charge, okay, two point charges, okay, is called the, or is, yes, it's called the R, right? R. So we call it R. So it means that, for example, if you have a certain quantity of charge, so suppose that this is a positive charge and this is a negative charge, Q2, so negative. And the distance between them, we call it is R, right? Call it is R. This is the standard letter, okay? So we say that for this case, this unlike charge attracted upon the fundamental law of electrostatics. So the force of attraction is directly proportional to the Q1 times the Q2, and the inverse proportional to the square of the distance, right? So that is the situation. So if these are situations, yes, so he said that don't worry about sign first, because this is, we call it's a force, attraction force, okay? It's attraction force. So then we come. So then we say that on this left-hand side, so we have now, this is question 3, okay? So we say that this proportionality sign, so we say that the force is tape. We say that replace the proportionality sign, right? Proportionality sign, right? Proportionality sign with equal sign and the constant K. What does it mean? It means that now replace this proportionality sign with equal sign and K as meaning proportionality constant. And what is proportionality constant? Proportionality constant. So we say that the magnitude of the force, this is equal now to the proportionality constant K times the product of the quantity of charge Q1 times Q2 over square of the distance between the two charges. So this is literally, so it means that literally, in general, many teachers, they used to teach in this way. But I would like to say that it's not a corrective formula according to the Coulomb, right? So Coulomb's mathematical equation, Coulomb's mathematical equations, okay? Mathematical equation, according to the physics books, is this, right? Is this. So what is it? Is force scalar quantity or vector quantity? It's a vector quantity. Is Q quantity, is charge scalar quantity or vector quantity? According to the property, you say it is scalar quantity. So if force is a vector quantity, we have to show its property of vectorial, of being a vector. So a vector quantity is a quantity which has both magnitude and direction. So this is the directions of the force, this arrow, right? So then we say that this is equal to proportionality constant, which we'll discuss this too soon. Okay, so this is Q1 times Q2, and then divided by the square of the distance between the two charges. But also we say that on this right hand side, we have a vector, we call it directional vector. So we call directional vector. What does it mean? This force has particular direction, right? So you cannot discuss electrostatic force without discussing the direction. Why? Because fundamental law of electrostatics has already stated, like each charge, repel, right? And like each charge, attract. So like each charge, repel. So there is the push force, right? And like each charge, attract. There is what we call it pull force, right? So that is great. So this is the U. This is we call it directional vector. So because in this course, or in advanced physics, we are not dealing too much with vectorial electrostatic force, or electrostatic force in terms of vectors. We are dealing with a magnitude, right? So the magnitude, so you have to recall what you've been told, that if you've been given a vector, for instance, which is A1, and then I, plus what you, let's say that B1, and then J. Okay? So we did that the vector, right? Remember that in Form 4 that we used to teach you about vector, right? In mathematics. So you say that the magnitude of a vector, this is equal to it. How do you find magnitude? So magnitude is the symbol first of all. So we can say that, so even this one can say A1 plus what B1, okay? And then sort of J1. So we say that vector magnitude of that vector can be the square root of vector component A1 square plus what B1, or we call it B1 what B1, this is not okay, B1 what B1 square. So this is the magnitude. But magnitude of a vector is scalar quantity. It's no longer what a vector quantity. So in order to convey this force to become a scalar quantity, we have to find the magnitude of this vector. So this is what so this is equation 4, right? So we say that the fifth step. The fifth step, we say that find the magnitude. Find the magnitude of what of equation what of a vector in equation 4. Okay, so the magnitude now we say that okay. So the magnitude of this force. This is equal to what? Magnitude of quantity charge 1 times quantity charge 2 times proportionality constant divided by the square of the distance But again, so you are finding magnitude of 40, but this distance, then we multiply by what? Directional vector. Okay, directional vector like this one. So now you have the magnitude of the force, right? So this is, so remember that. So that's why that we said, this is what? Coulomb's physics mathematical equation. If you pursue your undergraduate studies in physics, we'll find this one, right? But also you can say that another Coulomb's mathematical equation is in this form, right? But to simplify, in simple form, okay, in simple form, we say that force, electrostatic force, this is equal to proportionality constant times Q1 times Q2, or Q1 times Q2 times R squared. So this is just a simplified version of Coulomb's mathematical equation. If you have a question, ask in the comment section. Understanding is coming. Understanding is coming. Tell your neighbor, understanding is coming. Understanding is coming. Understanding is coming. This is the beauty of electrostatic. Okay? So that is all. Okay? That is all. Now let me take you into another direction. That proportionality constant. We say that now let us deal with proportionality. Proportionality. The first thing, what we have been, just to remind you, what we've been doing here, we want just to show you the constant, we call it the electric permittivity in the Coulomb's law, right? So firstly, we recall the fundamental equations of Coulomb's, which indicated the proportionality constant K, and the second equation that after experiments, main experiments in electrostatic of the charges, when they did a lot of studies and a lot of experiments, they come up with this equation. So you say that, okay, there's a relationship between this equation. So K, we can substitute K, that's what we say, that substitute equation 2 into equation 1. So in positions of K, we introduce the 4 pi perimeter of the free space. And this is the general equations, but this for the free space of the medium, we were indicating that this is the proportionality or the electric permittivity is a proportionality or the constant, right? So proportionality constant that's showing electric field. We'll tell you about electric field. Then we said in any medium, the electric permittivity is denoted as this symbol, right? As epsilon, right? The general formula of Coulomb's in any mediums is given as this product of 40. So he said that the force is equal to products of the quantity of charge Q1 and Q2 F over 4 pi permittivity of the medium times square of the distance. So this is permittivity of the medium. Don't confuse this permittivity of the medium with permittivity of the free space. This is specified medium, which is free space. This is for any medium, right? So now I want to take you on to fantastic last term of this lecture is called relative permittivity, or the electricity constant. However, that my students here, they're indicating that they are so saturated while we are still beginning. We are still building the foundations of electrostatic. We are still in introduction. Okay, so relative permittivity or the electric constant. Okay, the fundamental question, you know, always whenever I write a term, you know what is next thing. Define the term. That's how I used to learn. Well, really, I can tell you that what I've been taught, for what I'm teaching you, possibly that 10% is what I've been taught physically by a person or by a teacher. But 90% I've been looking myself and thinking around. How? These are the techniques that I'm using. When I write a terminology, regardless there's been defining those notes, I have to look at the definition first, then I go in detail. Right? Okay, so the first question, you know it. Can you state? What is? What is relative permittivity? At least I have to laugh because from the beginnings of this session today, I was so passionate about you. Because you have a great sickness, you have adapted it from your eldest brothers, that physics is complex, especially advanced physics. I would like to tell you that that is not true. It's just like some of you, they used to say that mathematics is a national disease. In Swahili, we say that hesabu ni ugonjwa wa taifa. And myself, I rejected that sentence. I said that mathematics is a beautiful way of solving real life problems. It's not difficult, it's not a disease. It's the solutions of many diseases that we are suffering as a human being. You believe that? Tell me in the comment section. You have to think differently. to come up with what I'm saying, because you have to verify. Because those who are telling you that mathematics is the disease, is the national disease, really they are failing. So they are demonstrating what they are saying. So if you say that it's a solution of the diseases, you have to demonstrate how. Okay. So what is relative permittivity or the electric constant? Well, so we have some definition. Relative is a ratio. So simply say that it's the ratio of permittivity of the given medium to the permittivity of the vacuum of the free space. So you say that simply relative permittivity is a ratio of what? Of electric permittivity of what? Of a given medium, of any given medium, which is not air. A given medium, okay? Of a given medium, okay, but it's not what? Air, to what? To the electric permittivity of what? Permittivity of free space, or we call it what? Free space, or we call it vacuum. That's the simple definition, and it's mathematical definition. So relative permittivity is equal to permittivity of the medium over permittivity of the free space. This is mathematically. So mathematically is the formula. Okay? So you say that relative permittivity is the ratio of permittivity of the given medium to the permittivity of the free space or vacuum. It's just like what? Relative density. It's the density of substance to the density of water. So in case of density, because I'm teaching physics also, especially O level, you have to make sure that also join in my online school that's called TANZANIA Online Ordinary Secondary Schools. Okay? So in the topic of density, we used to say that relative density is the ratio of 40 simple definitions, because we are teaching O-level students. Is the ratio of the density of the substance to the density of the water. So the reference density of anything is water. Is density of water. Similarly, in electrostatic, our reference medium is free space or vacuum, not water. You have to understand physics sequentially, don't jump around. So he said that this guy, relative electric permittivity is equal to permittivity of the medium over permittivity of the free space. Right? So what do you realize that? If you take the sitting point, what they say of relative density? What they say of relative density? It's unitless, does not have unit, similar to electric permittivity. So the relative permittivity, or is called in electrostatics, in electricity, we engineers, we just call it the electric constant. Very important, and we have the electric materials. We are going to discuss this concept in the last topic, that's called the capacitance, in detail. Okay? And we'll show you some examples of the problem. So you say that we say that in relative permittivity, electric permittivity, or the electric constant does not, okay, does not have what? SI unit. Does not have unity at all, including what? SI unit. Right? But again, another thing that we can express electric permittivity of any medium in terms of relative permittivity times what? The permittivity of the free space. Right? Are we together? Okay. So that is relative permittivity. We say that, okay, fine. Okay, relative permittivity, okay, the electric constant, that one. So, okay, so this is also important question, should be in your mind along the journey. Okay? Okay, along the journey. Well, so that is one of the questions. So now we can say that you can express the mathematical formula of 40 of Coulomb. Okay, of Coulomb. of Coulomb, the mathematical formula of Coulomb as function of 40 relative permittivity, right? So what the mathematical formula of this guy? First of all, first step, say that we call the electrostatic fundamental equation. F is equal to what? Is equal to, we say that is equal to what? Is equal to Q1 times Q2 of what? Over 4 pi, permittivity of the free space, and then what? R square. Right? R square. So that is the equation. You do remember. So this is the first equation. Then you have the second equation. So the second equation, we say that permittivity of the medium is equal to relative permittivity times permittivity of the free space. Right? So this is equation 2, and this is equation 1. So we say that now substitute equation 2 into equation 1. Right? So substitute equation 2 into equation 1, we say that force is equal to what? Is equal to Q1 times what? Q2, and then we have what? Here we have 4 pi relative permittivity times permittivity of the medium, R square. Beautiful. You have many mathematical formula of Coulomb. Why am I giving you all of this information? Because I want you to be untouchable in solving problems of electrostatics. That's why I'm giving you different formulas, because these formulas are the ones that used it to solve problems, right? Okay, so if that's the case, I want to leave the second equation or the second questions of the homework 3. Okay, I'm about to finish my session, otherwise I can keep on continuing, but this is question 2. So the Lord who has given this business, he said in my heart, Olenjolai, today it is enough. Okay? So listen the question careful. It's a thoughtful equation, but all the information, okay, are in this lecture or in this session. Relative permittivity, okay, relative permittivity of a medium, right? Relative permittivity can also defined as the ratio of 40, the ratio of force between two electric charge. Listen carefully. Make sure that you do this homework and submit in the comment section. Between two electric charges. Okay? Electric charges. Between two electric separated by a certain distance, separated by a certain distance, in vacuum to the force between two charges, between two charges, right? Separated by the same distance. Separated by the same distance. Okay? In another medium. Okay? So that's the sentence. So use the Coulomb's formula to justify sentence statement above mathematically. Mathematically means that, okay, yeah, mathematically. Add the question. You have to think. It's not define, mention the properties of electric charge, no. So the relative permittivity can also be defined, right? Can also be defined. Can also be defined. Can also be defined. Can also be defined as the ratio of the force between two electric charges separated by a certain distance in vacuum to the force between two charges separated by the same distance in another medium. Use the Coulomb's formula to justify the statement above mathematically. Very interesting question for the lovers of physics. Well, this is the end of this session. I thank God who have been with me in the preparations of this session. It has been a wonderful sessions to me. The way I've taught these sessions is quite different from the way that I learned for the first time myself, and even it's different. I taught electrostatics for 5 years. So I remember how I taught my previous students, my physical students. So this is special revelations that God giving me on teaching the national students, on teaching even that a large group of students, advanced students. So I thank God also have given you a chance to be with me, and I thank you also for taking your time and leaving your activities and your maybe the way of learning, and you joined me. So I thank you. May God bless you for what you have done. I would like to invite you in session 4 of the general introductions of electrostatics as the topic that we began, when I'm going to teach you how you can solve problems in electrostatics or in Coulomb's law by using the Coulomb's equations. So you'll be calculating force, you'll be calculating some issues, quantity of charges and whatever. So you'll be having a lot of examples, so a lot of problem solving from there. I think that almost we'll have 8 examples. Then I will teach about superposition principle, then we'll teach about some other laws, and then we'll be solving more questions as I gave you a promise. So join me in the next sessions, and remember that to subscribe and share these contents with your colleagues so you may enjoy the beauty of physics, and even that you think how you can apply this information to solve real life problems. So thank you very much. See you in that time. May God bless you.